السلام عليكم ورحمة الله وبركاته. grade 4. Inshallah in this video we are going to revise lesson 1 in unit 3, which is talking about waves. But before starting anything or talking about anything, let's say دعاء. اللهم لا سهل إلا ما جعلته سهلا أنت تجعل الصعب إذا شئت سهلا يا رب العالمين. اللهم إني أسألك فهم النبيين وحفظ المرسلين وإلهام الملائكة المقربين. اللهم إني أسألك قلبا خاشعا ولسانا ذاكرا شاكرا إنك على كل شيء قدير. If I say the word wave, what the first thing came to your mind? Of course, it's the sea waves. The first thing came to your mind when I say the word wave, it's the sea waves. What can you see in the sea waves? Some of you will tell me that it's movement. The water is moving. How the water is moving? Anything to move, it needs energy, right? So, if you want to define the word wave from this image or from this picture or from this movement, we can say it's a disturbance. Can you see the water is disturbing? So wave is the disturbance that carry energy. These disturbance carry energy from one place to another or transfer energy. So those sea waves carry the wind energy. The wind energy carried by these water waves or by these sea waves from one place to another. What about the other types of energy? Is there a wave or a disturbance that carry them or move them from one place to another? Yeah. Those speakers, they bring some salts and place them over the speakers, and then they turn it on. Once they turn it on, they saw the sand is moving in a random movement, in random patterns, as you're saying. This is the sound waves. These are the waves that carry the sound energy. This is the disturbance that carry the sound energy. Even light energy are carried on waves. There is waves that carry light energy from one place to another. And you can see this video, but be noticed that this video contains music. So if you don't like listening to music, you can open it and mute it. Mute the video. So after seeing all of that, can't we find the meaning of the word wave or the definition of the word wave? We can say waves are disturbance that carries energy, such as light and sound and wind energy. How it looks like or how it moves? It looks like this spring I showed to you in class, moving from side to side or up and down. This is the shape of the wave, or the waves that the people made in a game, a match. This is the shape of the wave. Slithering of a snake, the movement of a snake shows the shape of the wave. And also we can see the water wave. Sound waves. This is the shape of the wave moving and transferring energy. Will the amount of energy carried by the wave affect its shape? The amount of energy the wave carried from one place to another. Will it affect its shape? Of course. Can't you see? If this man threw a larger rock to water it, he is transferring larger amount of energy to it. So the shape of the wave will be larger and its size will be larger, the height larger, and the waves are going to be closer to each other. So the more the energy of the wave, the more its size, height, and the closer the waves are to each other. In page 149, we can find the meaning of the word wave, which is a disturbance that carries energy, such as sound and light. And here in question number 2, he's asking us to list some other examples of wave in everyday life. And how do you know the wave is strong or weak? Let's think about some wave we experience in our daily life, other than this water wave, or the water wave that carry wind energy. For me, I said the microwave. I'm experienced the microwave in my everyday life. There is energy inside this microwave that carried on waves, light energy, invisible light energy, and it heats food. And also the light waves coming from the sun. We experience it every day. And also the sound wave. We are experiencing it right now. The sound vibrations or the sound energy travels through the waves, and you can listen it once these waves move my sound to your ears so you can hear my voice. So I just tried this example, the microwaves that heat food, and sound waves as well. We know the strength of the wave. We know if the wave is strong or weak from its shape. Here is the shape of sea waves, and it's asking us, what would happen to the wave in this same pond if a larger rock were dropped into the water? Larger rock is dropped mean high amount of energy. So will the wave would be closer? Will the wave would be smaller in size? Smaller in size and large energy? Doesn't make sense. There will be fewer waves with less energy, and I give the wave, I transfer high energy to the water through the rock. Doesn't make sense. There would be a larger wave with more energy. It makes sense. We had two right answers here. So the wave would be closer together, the waves, and there would be larger waves with more energy. From this image of the wave, what can we see? What can we say? This is a matter, this dot is considered to be a matter or a particle or a material, and we all know that energy transfer through the waves. The wave carry energy and transfer it from one place to another. Will it transfer matter? If the energy on the wave passed by the matter, it will not affect it. Just raised up and down for passing, and it will not move it. So wave transfer energy, not matter. Some of you told me that, no, miss, when we were in the sea and the wave hit us, we moved. And you said it because it hits you, because the wave hits you, and hits you means it transfers some of its energy to you. But if it does not hit you like this dot, it just passed by it, it didn't transfer any of its energy to it, it will not move, it will just go up and down for the wave to pass. Like in this image, those people are riding the wave. The wave is passing by them and it doesn't move them from one place to another. It just raises them up high to pass. But if the wave hit them and transfer some of the energy that carried on it to them, maybe they will move, but only if some of the energy transferred to them. If they are just on the top of the wave and the wave is passing by them, it will not transfer them, it will not give them energy. I hope you understand this point quite well. Wave just transfer energy, it doesn't move matter. The aim of the wave or the job of the wave is to transfer energy, not to move people or not to move materials. If some of the energy of the wave transfer to this person or to the material, maybe it will move. But if it does not transfer any of its energy to this person or to this material, the object or the material will not ever move. If we talk about the sound energy, if the sound energy passed by you, will you move? Of course no, sound energy will never move you. Sound energy just move the sound. Sound waves. Sound waves will never move you. Sound waves just transfer sound. Sound wave will never move materials. It just transfer sound. It just moves sound from one place to another. You can see this video. In this video, you will see a practical experiment or a virtual experiment to prove that wave just transfer energy and doesn't move matter. Once the sea waves that carries the wind energy hit a large rock or hit the shore, it released its carried energy. Can you see how energy is releasing once the wave hit the rock? This changing in the shape of the wave due to the energy releasing. when the energy released. In page 150, we can find the shape of the wave at first, of the sea waves, rolling and rolling and rolling till it reached the shore and hit it, and the energy released. Imagine you're in the ocean. The water reaches your waist. How will energy in a small wave affect you as the wave passes? How will energy affect you, the energy of the water wave as the wave passes? For me, I will just move up and down for the wave to pass, and wave will complete transferring its energy without transferring me anywhere. It's just for transferring energy. How they think about buoys? Can you see these buoys? Haven't you ever seen it in the sea? And how it helps scientists to study waves? These buoys are placed on the sea to give scientists evidence or information about the strength of the waves or the strength of the upcoming storm. If it moves very fast, it means the storm is very strong. If it moves up and down very fast, it means the storm is very strong. But if it moves slowly, it means the storm is weak. Those buoys can tell the scientist how strong or big the wave are depending on how much they are moving up and down or back and forth. Those are the buoys. In question number 5, in page 151, they are saying, select the best word to complete this sentence. When ocean waves hit the beach, when the waves hit the beach, what is released? Is it energy, motion, or buoy? Excellent, it's energy. The energy released when the wave hit the shore or the beach. This is the end of session 1. In session 2, we talked about waves movement, how the wave move. And I bring you this spring. You remember the spring? And I told you that it moves maybe up and down or from side to side, depending on the type of energy it's carrying. It moves up and down or side to side, depending on the type of energy it's carrying. Let's revise the meaning of the wave. As we said, it's the disturbance in the medium that transfer energy. And it only transfer energy, it doesn't transfer matter. Transferring matter is not the purpose of the wave. Like for example, sound waves. Have you ever moved because a sound wave passed by you? Or have you ever moved because light wave passed by you? If you are asking me about the water waves, I told you it moves because the water wave transfers some of its energy to your body. That's why maybe you move. But if you are on the top of the water, it will not move you, just up and down for it to pass. And we said the more the energy of the wave, the more its size and height, and the closer the waves are. What about the shape? As I told you, it can be from side to side, like these images representing side to side wave. Side to side sound waves, side to side wave that transfer sound energy. Side to side sound energy waves, side to side sound energy waves. Up and down, these people representing the up and down wave, like the water waves. We said water waves, wave movement can be up and down or back and forth. Back and forth is same like side to side. Up and down or back and forth. Up and down like the wind energy that move through waves. This flag is moving by, show the waves of the wind energy, it's moving it. So it shows us the shape of the waves that transfer wind energy. And water waves up and down. Light waves, and put it in your mind. Light energy only transfers to up and down waves. Light energy, up and down waves. What about back and forth or side to side? Once I say side to side, you have to be sure that any sound energy transfer through side to side wave. Sound energy, side to side. Ultrasound, the ultrasound through which they see inside mommy's tummy, see the baby. These ultrasound energy, And I say ultrasound, sound transfers through side-to-side wave. Earthquake. The earthquake energy is transferring through side-to-side wave and sound sent by the bat to find food or know how to move. As you know, bat cannot see. It just sends sound. And when it sends sound, the sound came back to it to know the distance and to know if there's somebody around it or something around it. So this sound or this ultrasound that's sent by the pad is this ultrasound energy that's sent by the pad is transferred through side-to-side wave. Can you see? This is the earthquake energy, side-to-side, moving side-to-side, wave, moving from side-to-side wave, and make the sound, the ground shake. The ultrasound to see the baby. The ultrasound energy transferred through side-to-side wave. In page 152, we can see the shape of the wave that's moving up and down, up and down, up and down. And this slithering of the snake show us side-to-side wave movement, from one point to another, side-to-side wave movement. And those people do the wave at the game. They are showing us up-to-down movement, the shape of the up-to-down wave. And this satellite is placed in the space, and it sends us signals. Like for example, you know, when you're watching TV or listening to radio, this TV or the radio catch or receive the signal from these satellites that's placed on the space to show us what we are seeing in the TV. Those signals considered to be light energy, and these light energy transfer through up and down waves, invisible light signals, up and down waves movement. Question number 8, write a saying that will help you remember how energy and matter move as they travel in an up and down wave. How energy and matter move as they are traveling in an up and down wave. What is the up and down waves that you are experiencing in your life? The water wave. The water wave makes me move up and down as it passes by me. In page 154, you can see the side-to-side wave movement. Can you see it? Side-to-side, side-to-side. Compressed, released, compressed, and so on. Sound energy is the universal example of energy that transfers through side-to-side wave. Sound vibration, side-to-side wave. If we are comparing between sound and light energy, we can say that sound energy transfers through side-to-side or back and forth movement of a wave, back and forth or side-to-side wave movement, while light energy up and down wave movement. Light doesn't need a medium to transfer, while sound need a medium. You will ask me what that means, miss. I told you that sound need any medium to transfer it, solid, liquid, or gas. But light does not need any medium. The universal example of that is the sun. The sun is placed in the space and it gave us light. And the light can reach us from the space to here. Although in the space there is no air, there is no medium. But light can travel through the space where there is no medium. So it doesn't need medium. But for you to know, there is explosion sound over the sun. There is a huge amount of sound energy over the sun, because there's so many reactions and so many explosions happens over the sun. Boom, boom, boom sounds. But we can't hear any of that. Do you know why? Because there is no air in the space to transfer this sound to us. So for sound to transfer, we need medium. But for light to transfer, we don't need medium, as the example of the sun. And both of them will move forward to transfer this energy. In page 155, we have here a classification question, different example of different energy, and we have to say if it will transfer through side to side or back and forth, side to side or up and down for waves. Classify the examples by writing up before the up and down waves and PF before the back and forth wave, and remember back and forth is the same like side to side. Guitar being played. Guitar being played shows sound energy. Sound energy transfers through which kind of waves? Side to side or back and forth. Excellent. Sunlight energy coming through a window. Sunlight energy. Light energy transfer through up and down wave. Excellent. Boat bobbing in the water. Boat bobbing in the water. Wind energy traveling through water waves. Up and down. Super. Ultrasound of human heart. Ultrasound energy for human heart. Sound side to side. Excellent. Crowding. Crowd doing the wave at a basketball game. Up and down. Bell being rang. Trin trin. Bell being rang. Sound energy side to side. The last thing is the satellite, and I told you the satellite sends us light energy, light signals, up and down. This was the end of session 2. In session 3, we talked about the parts of the wave. We bring the wave, this movement of the wave, and we talked about each part of it. Look at the shape of the wave moving, transferring energy. What can you tell about it in 3 points? Maybe it consists of so many different points. The top, the base, maybe the distance between each top and the other, and so on. We are going to know the name of each part of this wave. Here we have a wave and different parts. We are going to know the name of its top, the name of its base, the name of the distance between the two waves, or the distance between the two tops, and half the distance between the top and the base. We're going to know the name of each part of it. Number 1, half the distance between the top and the base, we call it amplitude. Amplitude. And 2 is the distance between the two tops, and we call it wavelength. Wavelength. The distance between two successive tops or two successive bases are called wavelength. The top is called crest. So if you want to define the wavelength, we can say it's distance between two successive mean after each other, two successive crests, as the top is called the crest, and the base is trough, or two successive troughs. So we have crest and trough, crest and trough, crest and trough, wavelength, wavelength, amplitude, half the distance between the crest and trough, amplitude, amplitude, wavelength, crest and trough. Here we have the wave, moving wave, up and down moving wave. Maybe it's transferring light energy or something as it's up and down. Wavelength, the distance between two tops or two crests. So if you want to define each word, so we can say crest is crest, trough, amplitude, and wavelength. We can say crest is the biggest point on the wave, or the highest point in the wave, I'm sorry. Trough is the lowest point in the wave. Amplitude is half the distance between crest and trough, between two successive crest and trough. Successive mean exactly after each other. Crest and trough. Half the distance between this crest and trough is the amplitude. And the wavelength is the distance between two successive crests or two successive troughs. Two successive troughs, we have wavelengths, and two successive crests. This distance we call it wavelength, and you can watch this video to know the different parts of the waves, but I can't turn it on here because of the copyrights. Which wave has the biggest wavelength from those two waves? Which wave has the biggest wavelength? And remember that wavelength is the distance between two successive crests or two successive troughs. Can you see? This is a wavelength and this is a wavelength. Which one is bigger? This have longer wavelength, while this have short wavelength. In page 156, we can find the meaning of the word crest and trough and wavelength and amplitude. And he's asking us to describe two distances that are the same in the adjacent waves. What are the two distances that are the same in the adjacent wave or in this wave? Exactly. It's the distance between two crests or two troughs, two successive crests or two successive troughs. This is the same distance and we call it wavelength. In page 157, we can see different waves with different amplitude and different wavelength. From your thoughts or from your mind or logically, if I show you those two waves, can you tell me which one has the highest energy? The one with low amplitude or the one with high amplitude? Which wave is transferring the highest amount of energy? At the beginning of this revision or this session, we say the more the energy, the bigger the wave, the higher the wave. So of course, the one with high amplitude has more energy. So if you want to complete those sentences, we can say the wave on the top has smaller amplitude. The wave on the top has smaller amplitude. As you're seeing, amplitude is half the distance between the crest and the trough. Small amplitude, low amplitude, but this have high amplitude. Okay, thus the wave on the top has less or more energy? Less energy, excellent, than the wave on the bottom. Here we have two other waves, one with shorter wavelength and one with longer wavelength. The wave on the top has than the wave on the bottom. The wave on the top has shorter wavelengths than the wave in the bottom. In question number 13, we have to select the word and place it in the space. Number 1, the top of the wave is called the crest. The bottom of the wave is called the trough. The distance between two crests of the wave is called the wavelength. And the distance between the crest and the resting line, or have the distance between the crest and trough, is the amplitude. Excellent. This was the end of session 3. In session 4, we talked about sound and what is sound and how the energy of the sound affect the shape of the wave. We all know that sound is vibration, and these vibrations need a wave or a medium to travel through it from one place to another. When we hit the wave, you can the drum, you can hear sound. What do you see or feel? We can feel or see the vibrations of the sound. When we beat the drum skin, it vibrate and it causes the air to vibrate, and those vibration is a complete back and forth or side to side movement. It needs a side to side wave to travel through it. If you want to describe sound, we can talk about two characters in the sound. Sound be characterized by two characters, which is loudness or volume. Loudness, sound can be loud or quiet or soft. And the pitch of the sound. The pitch of the sound, what is the pitch? The pitch is how sharp or rough the sound is. How sharp or rough the sound is. We have high pitch sound and low pitch sound. We have loud sound or quiet sound or soft sound. Okay? The loudness of the sound will change. What it will change in the wave, in the sound wave? If the sound is loud or quiet, it will just change the amplitude. The higher the amplitude, or the more the amplitude, the louder the sound. The louder the sound, the more energy the sound has. What about the pitch, high pitch or low pitch sound? It changes the number of waves. Like, for example, my sound or this sound. I have a high-pitched sound, so the wave energy that will the wave that will carry the sound energy will consist of so many waves, so many number of waves. So the wavelength is going to be small because there is so many waves. But if I had a low-pitched sound like this sound, the number of waves will be less and the wave energy is going to be larger. Okay, you got it? High-pitched sound has more waves. Low-pitched sound has less waves. Fine, and that will affect the wavelengths. The more the waves, the smaller the wavelengths, because they are going to be closer to each other. But the less the wave, the larger the wavelengths. Okay? So, loudness, it changes the amplitude of the wave. The louder the sound, the larger the amplitude, or the higher the amplitude. But the pitch will change the number of the waves. The higher the pitch of the sound, as the sound is high pitched, the more the number of waves, the smaller the wavelength. If I showed you those two waves, and I'm talking about the loudness of the sound, can you tell me which wave show me loud sound and which one showing me quiet sound or soft sound? As we say, the louder the sound, the higher its energy, the higher the amplitude. So this is soft sound because it has smaller amplitude, and this is loud sound because it has larger amplitude or higher amplitude. If I'm talking about high pitch and low pitch sound, can you see the more the number of waves, so the higher the pitch, and as the number of waves becomes more, the wavelengths become smaller. Can you see? Larger wavelengths, smaller wavelengths, larger wavelengths means low pitch sound, smaller wavelengths mean high pitch sound, more waves mean high pitch sound, less waves mean low pitch sound. Okay, so the more the waves per second, the higher the frequency. Forget about this word, the higher the pitch. Like thunder and mouse squeaking. Mouse is squeaking, squeak, 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 high pitch sound. But the thunder and lightning, boom, boom. This is low pitch sound. That's why we have small, little waves, larger wavelengths. So low pitch sound. Here, more waves, squeak, squeak, the high pitch sound. More waves, smaller or shorter wavelength. This is rough sound or low pitch sound. Less waves, larger wavelength, more waves as the high pitch sound, and smaller wavelength because of the short sound, the high pitch sound. And we know the higher the pitch, the more the number of waves, the shorter the wavelength. If I showed you those three waves, three images of waves, and I asked you to classify the highest pitch, the middle pitch, the lowest pitch, can you tell me which one had the highest pitch, HP and MP and LP? The highest the pitch, the more the number of waves. The more the number of waves, less waves, lowest waves, and larger wavelength, smaller wavelengths, the smallest of them all. So we can say this is the highest pitch, and this is middle pitch, and this is low pitch sound. In page 158, we can find different sounds, and we can say that we can find the meaning of the word loudness of volume that affected by the amplitude. Here is the sound of the airplane, and we know it's very loud. So loud sound with high amplitude and high energy, and this is the shape of the wave. Can you see it's higher in amplitude and have high energy, of course. The sound of the hummingbird or the songbird, it's very soft sound with small amplitude and less energy. Soft sound is low amplitude and low energy. In page 159, we can find another sound, the dog whistling. Can you know? Do you know what's the whistling, the dog whistling sound? When it's making this is the dog whistling. It's high pitched sound. High pitched sound, so more waves and less wavelength. High pitched sound, more waves and shorter wavelengths. This is the sound of the flute. The sound of the flute is low pitched sound. Low pitched sound means less wave and longer wavelength. Here we have different objects that make sound, and we have to classify them in high amplitude. And high amplitude means loud sound, and low amplitude. And low amplitude means soft sound. Number one is line roaring. Lion roaring. Lion roaring. The sound of the lion, is it loud or quiet? Is it high amplitude or low? It's high amplitude. Train whistle. The train whistle. If you are away from the train, you'll hear this whistle as an alarm, as the train is saying, I'm moving. Ooh! High amplitude, loud sound for you to hear. Cat meowing. Meow, meow. Soft sound, low amplitude. Water dripping. Ting, ting. Very low amplitude, very soft sound, not loud at all. E, fireworks exploding. Fireworks, very loud. We can hear it when it's up high in the sky, so high amplitude. Flag snapping in the wind. It hardly makes sound. It's very soft, low amplitude. Trumpet blowing. You know the trumpet is a musical instrument. When you blow in it, it makes sound, and this sound is very loud, high amplitude. Fire cracking. You know the sound of the fire when it's burning something? It's low amplitude or a soft sound. In page 160, we have to select the words that make each sentence correct. All waves have space and space. Of course, wavelength and amplitude. In sound wave, the amplitude is also called the volume. Excellent. The louder the sound is, the larger the amplitude. Sounds that are soft means quiet, have smaller amplitude. Excellent. So all the wave amplitude and wavelength. In a sound wave, the amplitude is also called the volume. The louder the sound is, the larger its amplitude. Sounds that are soft have smaller amplitude than sounds that are loud. Thank you so much, grade 4. Hope you understand the lesson quite well. Study hard for your assessment. Inshallah, tomorrow is today is Saturday, so Sunday is gonna be your assessment. Study hard for it. Do your best because you are the best. Thank you so much. Bye bye. Assalamu alaikum wa rahmatullahi wa barakatuh.